Hey there, future pharmacy techs. Welcome to Pharmacy Tech Success, your go-to channel for everything you need to pass the PTCB exam and kickstart your career. Whether you're just starting out or looking for tips to ace your certification, we've got you covered with easy-to-follow tutorials, practice questions, and insider tips. Let's make your pharmacy tech journey a success. Subscribe and turn on notifications. Today, we'll be talking about conversions between measuring systems. Okay, we'll start with a problem and we'll figure out 3 ways to solve this problem. All right, so let's go ahead and dive into this first problem, and it reads, for example, if a medication is available in a concentration of 10 milligrams per ml and the prescribed dose is 50 milligrams, you would calculate. So what they want us to figure out is how many milliliters are required for a 50 milligram dose. I'm going to be showing you 3 ways to solve this problem. The first one is your need versus what you have. Right? Remember, they're telling me that I need a 50 milligram dose and I have a concentration of 10 milligrams per ml. Okay, so let's go ahead and start dividing. 50 divided by 10 equals 5. Milligram divided by milligram is canceled out. The only unit I have left is milliliter. Okay, that is my need versus have. Now let's go ahead and move into ratios and proportions. R and P, right? So for ratios and proportions, remember my ratio here is 10 milligrams per ml. So every single milliliter will contain 10 milligrams of this medication. On the other side, which is separated by an equal sign, remember we are going to, in ratios and proportions, we are going to be separating our fractions with an equal sign. On the other side, I need a 50 milligram dose, and the question is, how many milliliters would that be? So a couple of things that I want you to take a look at here. My milligrams are going to be on the same side and my milliliters are going to be in the same side. What's cool about ratios and proportions, it does not matter how you set up the initial fraction, the other side just has to match it. So if I were to set it up this way, 1 milliliter contains 10 milligrams of medication, that is totally fine. Just on the other side, I would have to put my X at the top, right, for milliliters, and my 50 milligrams here at the bottom. Either way, you are going to be multiplying, you're going to be cross multiplying 10 times X, so 10 times X, which equals 10X, and 1 times 50, 1 times 50. See, doesn't matter how you set it up. As long as the other side matches, your units match, you should be okay. So 1 times 50 equals 50. Now remember, in order for us to cancel out this 10, if you remember your basic algebraic equations, 10 divided by 10 cancel. Remember, we have to do that to the other side. 50 divided by 10, which equals 5. And remember your unit, milliliters. All right, and next up will be dimensional analysis. All right, so for dimensional analysis, and I'll just put DNA there. One thing that I want you all to consider when working with dimensional analysis is always starting with the unit of interest. In this case, my unit of interest, what they're asking me to solve for is milliliters. They're asking me to find out how many milliliters I would need for a 50 milligram dose, right? So that's gonna set the way we're gonna set the problem up. All right, so I know that I have to start my problem with milliliters, and the only thing that has milliliters in it is my concentration, right? They're telling me that this medication is at a concentration of 10 milligrams per milliliter. So 1 milliliter will contain 10 milligrams of this particular medication. Now, on the other side, we are going to be separating in dimension analysis. We're going to be using a multiplication sign to separate our fractions. Okay, so on the other side, now I want to keep my milliliters, but I want to cancel milligrams. And the way to cancel milligrams when I'm multiplying is to put it on the opposite end. So if it's at the bottom, we're going to put milligrams at the top. That will help us cancel out the units. I remember they're asking me for a 50 milligram dose. How many milliliters would that be? And in this case, I'm not using X. I'm going to be using a 1 once I get to my question. So how many milliliters for a 50 milligram dose? Remember how to multiply your fractions? We're going to be multiplying to the right. So 1 times 50 equals 50. 10 times 1 equals 10. 50 divided by 10 equals 5. Oh, sorry. $50 divided by 10 equals 5. And remember your unit of interest, milliliters. It is crucial that you guys remember to place your unit, because you may have the exact same numerical answer but with a different unit. So for example, the PTCB exam might put A equals 5 mLs, B equals 5 milligrams, C equals 5 grams, D equals 5 liters. So if you remember what you're working with, you're always going to be choosing the right answer. As long as your setup is correct, there's no reason why you should get it wrong. Thank you guys so much for joining me today, and we'll see you on the next one.